All right, we're checking out expressions in like terms. Again, let's zoom in on this modeling real life scenario. And I got to tell you, the goal of this is just to kind of help you or ask you to look at this from two, maybe more points of view. And what's the goal of that? I mean, so that, because you could probably think of one way just by yourself, like this is here, this is you, and you're thinking this is your thought bubble. You think of at least one. But I want you to be able to go, you know what? I could think of 1, 2, maybe even 3. Like, I want this to be you. Okay? So right here, let's read this. Each person in the group is buying an evening ticket, a medium drink, and a large popcorn. How much does the group pay when there are 5 people in the group? So first thing is I realize that you guys might not like word problems. I kind of understand that. I kind of feel that way a lot of times too, because I'm just getting nervous and I'm like, this isn't as simple. I got to think of it myself. But how are you going to take anything down that's big in life? You're going to do it one step at a time. So let's check out what they're buying. They're buying an evening ticket. Well, here is the evening ticket right here. Costs $7.50. So let's write that out here. $7.50. And then they are going to get a medium drink. Medium drink right here. That's $2.75. And let's see, a large popcorn. That is right here. It's $4. Okay. And then now it's just, okay, well, how much? That's a question statement right there. How much? How much does the group pay when there are 5 people in the group? So we want to know, how much are they going to pay if there are 5 people? All right, well, I got to be honest with you. I'm pretty sure this guy right here, the one idea guy, could figure this out. He would say, well, listen, we're just going to add these up. Okay, you get 5 there, you get 12 here, you get 14 here, right? They've come up with that, and they realize that I'm just going to multiply it by 5, and we get that it would cost $71.25. If you're thinking, wow, he's a genius, it's right there. There's the answer. So this is one idea. And if you come up with that, great. But now I want you to try and think through maybe a couple other ways to approach it. Like right here. We did this before with the guy running track. We said, hey, we have a number of tickets, and we know it's 5, but what if it was just an unknown amount? Like, we don't know how many people are coming to the movies. Let's call it X then. And the cost per ticket, how much was it? It was $7.50, okay? $7.50. And then we still don't know the number that we're going to need, but the medium drink, it cost $4. And then the large popcorn was $4. That's okay. We'll still keep it this way for now. And then write $2.75 here, because that was the other one, right? Yeah, that was the drink. So if we were to write it like this, it would actually end up looking like this, right? Because what you're doing each time is you're going to be multiplying the number of things times the price. I mean, that's technically what happens over here is if we were to just break this down, 4 people times 5, that'd be $20, right? And then we could kind of separate that out, and this would then be the cost. Once we take away $20, would be the cost of 5 of these plus 5 of these, right? And if you're thinking, no, I don't quite see that, I'm telling you that's what would be happening, right? Is when you have this times this, it's how much you're paying for the ticket times that many people. So this is another way you could look at it. So now you're this guy over here with 1, 2, or 3 ideas. So let's see, we've gotten the first idea. We've got, the first idea, the second idea. How about a third? Well, here's the third. The third is, what if you wrote it like this? And you might be thinking, well, how is that really any different? They're hinting at this idea of distributive property, but I'm not going to talk about it right now. They're just saying, hey, listen, what if you just did like the first guy did and you added all these up and then you just multiplied it by x, our unknown? Well, so you could just do this. You have this right here. And if you're thinking, well, how is this helpful for anything? Well, the idea is that you technically took the approach of going to the movies, buying this stuff, and approached it from 3 different angles, so to speak. Now, one of the angles that I like to kind of bring up on this is the unknown, the unknown, the unknown. Because what if you're, instead of just going to the movies, what if you're like, you own the movie theater? We got a young man named Royal in our class, so this is clearly his movie theater. Royal wants to make some money. Of course, he's not giving away this. He didn't buy a $10 million movie theater just so that you could have free popcorn, right? So what he's doing is he's over here thinking, this is maybe how he would set it up. Because he's not just trying to sell 5 tickets. He's maybe thinking, how do I make, $15K a day? And he's approaching it from, okay, well, if this costs $4 and this costs $275 and this costs $750, how does he achieve that? And I'm not expecting you guys to figure that out. I'm just saying that these approaches here, these different ideas that I've mentioned, maybe they are relevant, maybe they are useful to someone who needs those ideas. So maybe you don't need this third idea, maybe you don't need that perspective, but it could be useful. Does that make sense? So that was our approach here. And pretty much what I want to do now is jump straight into helping you with number 7. So if you are here to try and get info on all these, then cool. I'm going to jump into number 7. You're on a hike, and each hiker carries the item shown. Write and interpret an expression in simplest form that represents the weight carried by X hikers. And then it also goes on to say how much total weight is carried when there are 4 hikers. So you could think of it, like we did previously of, okay, 3, 4, plus 3, 4, plus 3, 4, plus 3, 4. I mean, you could do that, but that gets real annoying real fast. In fact, I was annoyed just to have to write it that many times. Or how about 3.4 times x, which, as we know, is technically 3.4 times 4, right? And then same thing here. This is 4.6 times x, 2.2 times x. So this would be 4.6 times 4, 2.2 times 4. But they said, hey, we want you to write and interpret an expression. So here we go. I'm saying if you did 3.4x plus 4.6x plus 2.2x, this would equal the total weight for an unknown amount of hikers, right? And then we could write it another way. We could say 3.4 plus 4.6 plus 2.2, all of that then times x, and guess what? That also equals the total weight for an unknown amount of hikers. And now let's multiply. Let's put a 4 right there and right there and right there, or just right there. So how are we going to do that? Well, let's add this up. So 3.4, in fact, here, I'm not going to try and do it in my head. I'm going to do it on paper for you guys, so to speak. 4 and 6 is 10, plus 2 is 12. 1 and 3 is 4, 4 and 4 is 8, 8 and 2 is 10. So 4 hikers are carrying 10.2 pounds total. That's how much this altogether would be if you had 4 times each one of those. And then I know that we just did that one. I'm going to jump into the last word problem here. Now, you might also have noticed, and if you didn't notice, hopefully you did, your own word problem that would be like this one. And you did it on the back here. That was kind of the hope for that one. And I'm not going to do that for you, but let's do this one. Find the earnings for washing and waxing 12 cars and 8 trucks. Justify your answer. By the way, this just means kind of like, tell me why you're right. What did you do that made you right? Okay, so washing and waxing means we're going to do both of these, kind of like that, okay? One thing that might have tripped you up is maybe you did it like this. You were thinking, oh, I'm going to wash, and the wash is $18. It's not exactly true, because we have 12 cars, and a car is both of these prices, and we have 8 trucks, and trucks are both of these prices, okay? So to wash and wax a car, it costs $20. 8 plus 12 is 20. And to wash and wax a truck costs $25. We want to multiply this by 12. We want to multiply this by 8. This becomes 240. This becomes 200. And so we get total, it's $440 to do all of that. And if you're like, okay, so justify your answer. This is what I mean. My writing all this communicated that. At the same time, if I need to write a sentence, if you wrote a sentence, here's what that sentence could look like. 12 cars. Let's start over. It costs $20 to wash and wax a car. 12 cars would cost $240. And then we would continue. It costs $25 to wash and wax a truck. And so then 8 trucks. Oh, that is a really ugly looking spelling of truck. Truck would cost $200. And then you would add those two up and get $440. And if you're like, I can't read any of that, these little marks were just to say it costs to wash and wax, because I use those words up here and I'm just repeating the same idea. So anyway, that's how you do those last 2 word problems right there. Right here, let's walk through these. You are supposed to simplify the expressions. All that means is if we had an equal sign, we might be trying to solve because this is an equation, but we don't have that. We just happen to have 8 sandwiches. And if you're like, why is it sandwiches? It's really anything. It doesn't have to be sandwiches. But I'm just going to stick with it for now, I guess. Or go back to money. Go back to insults. You know, all the stuff that we've been doing. This is positive 8. This is negative 11. This is positive 6. They all have an S. So there are 3 like terms here. Okay? And those 3 like terms can be combined. So we just are going to start from left to right because of PEMDAS, right? So here we go. 8 minus 11 is negative 3S plus 6S. That's 3S. Let's just go down from here. 4P. That thing's got a P. This thing's got a P. Oh, that thing's got a P. 4P minus 5P. Right here, 4P minus 5P is negative 1P. Minus 30P, we get negative 31P. 2/5 Y minus 4 plus 7 minus 9/10 Y. This has a Y and this has a Y. So let's combine them. There's a couple ways you could do this. This is 0.4Y and this is negative 0.9Y. If you were to combine those, you would get negative 0.5Y. So you could do it like that, or you could say, listen, 2/5 is really 4/10, and 4/10 minus 9/10 is negative 5/10 Y, which is also negative 1/2 Y. So however you want to look at that, we got negative 1/2 Y. okay? And then last but not least is just negative 4 plus 7. How do I know it's negative 4? Because there's a minus sign right there. Negative 4 plus 7. There we go. Number 2, 4b minus 24 plus 19. This guy has no like terms. He's just 4b. But these guys, they are both constants, which makes them like terms. I mean, just like, actually, I guess we didn't have any other constants over. Oh, yeah, we did here. These are constants, so that's why we were able to just go ahead and simply add them. So right here, we have negative 24, and I'm going to add 19. That is negative 5. 4.2v minus 5, well, can't do those two, but I can do 4.2v minus 6.5v. And if you're like, I don't know how to do that, okay, here's what I'd do. I know that this subtracted by this would give me a negative number. How do I know that? Because if I just think for a second, if I had $4.20 and somehow, like when I swipe my card, the card takes out $6.50, well, now I got a bummer because I have negative $2.30. And if you're like, but wait, you wrote it like 6.5 minus 4.2, and that's not what this says. But this is the concept. And when I get 2.3 at the end, I need to make it negative. So I have negative 2.3v minus 5. This 5 has no friends, so he just drops straight down here. Okay? Last one. Yay, fractions. Negative 2/3 c, 14c. Negative 2/3 plus 14. Fun. So, and then I realize that I have dropped my c, but I know that in the end, this is going to have a c. So, you could do common denominators. You could also stop and think, hang on, if I were on a number line and I was at 14 positive, right, because that's positive 14, and then I were to go in the negative direction 2/3, well, would I make it all the way to 13? No, I would end up at 13 1/3, right? Because it takes 3 thirds to go from 13 to 14 or backwards, right? So that's why it's 13 1/3. Or if you don't want to think of it that way, that's fine with me. Let's zoom in and do like the actual math of it all. So let's erase this 14 temporarily because I'm going to make it 14 over 1. And then I'm going to multiply this by 3 over 3 to get negative 2/3 plus 42 thirds. Wahoo. This gives us 40 thirds, which, like I said earlier, is technically 13 1/3. If you don't believe me, this is 39 thirds would be exactly 13. So anyway, that is 40 thirds C. Okay? And then last but not least is we have these two constants. They're also like terms. Let's just scooch over here and do it. Negative 9/5 plus 3/10. Okay? Let's make common denominators. So we get negative 18/10 plus 3/10. If you're a little nervous about this, just focus on the top right now. What is negative 18 plus 3? Well, that would be negative 15, right? So you end up getting negative 15/10, which can be reduced to negative 3 over 2. So we have 40 over 3c minus 3 over 2, and that's your final answer. So that is all the talk for expressions in like terms. Assignment number 2. Let me know what questions you got. See ya.